Students, see, this is polymers, new chapter. First, what are polymers? You have any ideas? That means the polymers means the polymers term is defined as a very large molecule. That is, very large molecule having very high molecular mass. That is, 10 power 3 to 10 power 7 atomic mass unit. So, a large number of molecules. Then, that means the larger number of molecules joined together, the repeating structural units are on a large scale. That is known as monomers. That means the repeating structural units derived from some simple and reactive molecules, that is called monomers. Okay, this monomers, the repeating monomers unit converts to polymer. That process name is called polymerization process. So that means monomer converting to polymer. So this process name is called polymerization process. So monomer converts to polymers. That process is called polymerization process. For example, ethene converts to polyethene. That means the double bond converts to single bond. So the repeating structural unit. The NCH2 double bond CH2. That N indicates number of the molecules. The number of molecules mean that's maybe 100, 200, 1000, whatever it is. That's why simply indicate N. So NCH2 double bond CH2. That means ethene. This ethene undergoes a polymerization process. It's getting a repeating unit. That means, see, the double bond converts to single bond. So this indicates the number of CH2 groups joined together. So that this N indicates here, suppose 100 means here 100 numbers of the repeating unit. So we can't write in that 100 numbers, 200 numbers in our class notebook. So simply just put like this. This indicates the change is going on. Okay. Then this converts to, this is the repeating unit. Then this finally formed CH2 bond, CH2 and N. Okay, so this double bonds converts to the single bond. That means this is ethene and this name is polyethene. Okay, that is a polyethene. Polyethene means polyethene is a polymer. So here this is a monomer and this is a polymer. The monomer converts to polymer. This process is called polymerization process. And one more example is hexamethylene diamine. So CH2 6 times, that NNH2 CH2 6 times and NH2. This is hexamethylene diamine. The hexamethylene diamine react with the adipic acid. Adipic acid HOOC CH2 4 times and COOH. So this is adipic acid. This adipic acid and hexamethylene diamine, that is this one monomer and this one monomers. So it undergoes a polymerization process. It converts to polymer, that is nylon 66. So this is a polymer. The nylon 6 is like this. NH CH2 6 times. Look at this. CH2 6 times. Then NH. Then connecting this C double bond O CH2 4 times, then C double bond O. That's mean this is a repeating unit. This is the main unit. This is called nylon 6, 6. Okay, look at here the NH2. So the remaining H, another one NH2, so that NH CH2 6 times, then the NH, this connecting of the COH, because one of the water molecules are removed here from one H and from one OH. So the removal of water molecule like this, suppose the NH, like the NH2 like this, mean the OH and H2. So H2O will goes out. The remaining is what? C double bond O. So that CO. So that I am writing like this: C double bond O, CH2 4 times. Again the next repeating unit. So like this. So the nylon 6,6. Why nylon 6,6 mean? You have to count the number of carbon atom in this unit. Look at here. Totally CH2 6 times, so that 6 carbon atom from hexamethylene diamine, and 4 CH2 4 times 4 carbon atom plus 1 5 plus 1 6. So totally 6 carbon atom from adipic acid. That is why the name is nylon 6,6. Okay, student. Classification of polymer. See, the classification polymer, first classification based on source. Few types are there. Classification based on source. Second one is classification based on structure. Classification based on structures. Then third one, classification based on mode of polymerization. Classification based on mode of polymerization. Then fourth one is classification based on the molecular force. Then the last one is classification based on growth polymerization. Growth polymerization. So these are the classification of polymers. What are the classification based on source, the classification based on the structure, classification based on the mode of polymerization, and classification based on the molecular force. The last one is the classification based on the growth polymerization. So first we will discuss the classification based on the source. The based on the source means the naturally occurring, that is the first one is natural polymers. The naturally occurring called natural polymers. So natural polymers, synthetic polymers, semi-synthetic polymer, and third one is synthetic polymer. First, natural polymers. What are natural polymers? That means they are naturally occurring. That means the polymers are found in plants and animals. Found in plants and animals. Example, proteins, cellulose, starch, some resins, natural rubber. So these are called natural polymers. Then semi-synthetic. That means semi-synthetic means natural and synthetic. That is why they are called semi-synthetic. That is cellulose derivatives. Usually it occurs from the cellulose derivatives. The cellulose derivatives like cellulose acetate, cellulose, that is cellulose acetate, nothing but rayon. Then cellulose nitrate, like this. These are the this examples, usual example of subcategory of these compounds. Okay, this is the semi-synthetic polymers. Then third one is synthetic polymer. This is completely man-made. The completely man-made. That is the plastic like polymers, polyethylene. The polyethylene means plastics. Then synthetic fiber. Synthetic fiber. That is synthetic fiber is nothing but there is nylon 6 already. I just before discussed nylon 6,6 and synthetic rubber. Synthetic rubber. Synthetic rubber is that is called Duna. Yes, we will discuss later this. And these are using day-to-day life. That is the synthetic polymers only we are using day-to-day life. Okay, student. Next, the classification based on the structure. This is the classification based on source. Now next is classification based on the structure.